Hey everyone, and welcome back to Complicated Stuff on the Girl Has It All channel. I'm Thomas, and I'm super excited for our 20th deep dive.
Wow, 20 already.
I know, right? Time flies when you're having fun exploring the complexities of the universe. And today, we're tackling a topic that's really blowing my mind. Altermagnetism.
Ooh, that's a good one.
It's like the new kid on the magnetism block, and it has the potential to, well, kind of change everything.
It really does. It's like we've discovered a whole new way for magnets to work. And to understand why it's so groundbreaking, we need to start with the basics.
Okay, so Magnetism 101. Most of us know about those classic fridge magnets, right? The ones that just like cling on for dear life.
Exactly. That's ferromagnetism. Imagine tiny little compass needles all lined up inside the magnet, all pointing north.
Yeah, that's how I always picture it. So they're all working together, creating that magnetic force.
Precisely. But then there's antiferromagnetism, where those tiny compass needles are all jumbled up, pointing every which way.
So they cancel each other out.
Exactly. No magnetic force. Well, ultramagnetism is kind of like antiferromagnetism, but with a twist. The tiny compass needles are still paired up in opposite directions, but they're arranged in a way that creates a tiny magnetic vortex.
A vortex, like a whirlpool.
Exactly. It's like a tiny whirlpool of magnetic energy.
Okay, now that's just cool. But how do we even know these tiny whirlpools exist? We're talking about something incredibly small, right?
Right. And that's where things get really interesting. Scientists have developed these incredible tools and techniques to study magnetism at the atomic level.
Like what?
Well, one technique is called neutron scattering. It's like using a super sensitive probe to map out the magnetic landscape at the atomic level.
So they can actually see the direction of those tiny electron spins.
Not literally see, but they can detect the patterns and figure out how those spins are arranged. And because ultramagnetism has that unique twisted spin arrangement, it creates a distinct signature that scientists can recognize.
So it's like each magnetic state has its own fingerprint. That's pretty amazing. But let's talk about why everyone's so excited about ultramagnetism. I keep hearing about something called Spintronics. What is that?
Instead of using the flow of electrons like we do in our computers and phones today, Spintronics uses the spin of electrons to carry information.
Okay, so instead of electrons flowing like water through a pipe, we're talking about harnessing their spin, like their internal rotation.
Exactly. And ultramagnetism could be a game changer for Spintronics because it allows us to create these unique spin textures, these tiny magnetic whirlpools, which we could use to store and process information in a completely new way.
So we could have devices that are smaller, faster, and use way less energy.
That's the idea. And that's just the tip of the iceberg. Some researchers believe ultramagnetism could even play a role in developing high-temperature superconductors.
Superconductors. Those materials that conduct electricity with zero resistance. Okay, now you're really blowing my mind. Lossless energy transmission would be revolutionary. But before we go too far down that rabbit hole, let's go back to those magnetic whirlpools for a second. What makes certain materials create these whirlpools and others not?
It all comes down to symmetry. The way atoms are arranged in a crystal, its symmetry plays a crucial role.
So it's like the architecture of the crystal dictates how its electrons behave.
Precisely. And specific symmetries can actually unlock this unique altermagnetic state, giving rise to those swirling magnetic fields. It's incredible, really.
It really is. But tell me, are there any environmental benefits to this whole ultramagnetism thing? Because with everything we're talking about, energy efficiency, new materials, it makes me wonder if this could be good for the planet too.
You're thinking along the right lines. One of the most exciting things about ultramagnetism is that it can occur in materials made from common elements, unlike some traditional magnets that rely on rare earth elements.
Ah, I see. So we could potentially create these incredibly advanced materials without relying on those problematic rare earth elements.
Exactly, which is a huge win, both for technology and the environment.
It sounds like ultramagnetism could be a real game changer on so many levels. Okay, so we've covered a lot of ground here. Mind-blowing magnetic whirlpools, the promise of super efficient spintronic devices, and the potential for a more sustainable future. It's almost too much to process. What are some of the key takeaways you want our listeners to walk away with?
Well, I think the biggest takeaway is that ultramagnetism is a fundamental shift in our understanding of magnetism. It's a reminder that there's still so much we don't know about the universe, and even the most well-established theories can be challenged and rewritten.
The power of scientific curiosity.
Absolutely. And that's something we want to encourage in all of you listening. What wild theories do you have about the future of magnetism? Where could this discovery lead us? We'd love to hear your thoughts.
And maybe we'll even feature some of them on our next episode.
Because who knows, maybe one of you listening right now will be the one to unlock the next big breakthrough in the world of altermagnetism.
All right, we've covered a ton, but we're just getting started. Stay tuned for part 2 of our deep dive into altermagnetism, where we'll explore how scientists are studying these magnetic whirlpools and what challenges they're facing in bringing this revolutionary technology to life. Don't go anywhere.
Welcome back, everyone. I'm still thinking about those magnetic whirlpools.
Me too. It's like nature has these tiny little raves going on at the atomic level. But I have to admit, the more we talk about this, the more I wonder, how do scientists actually study something so tiny? You can't just, look under a microscope and see a magnetic whirlpool.
You're absolutely right. It takes some serious scientific firepower to study altermagnetism. Scientists use techniques like neutron scattering and X-ray magnetic circular dichroism.
Yeah, I'm going to need you to break those down for me.
Sure. So basically, neutron scattering is kind of like using a super sensitive probe to map out the magnetic landscape at the atomic level.
Yeah.
And X-ray magnetic circular dichroism, well, that allows them to see the direction of those electron spins.
Okay, so they're not literally seeing these whirlpools, but they're using these high-tech tools to map out the magnetic fields and figure out how those spins are arranged, right?
Exactly. It's like using a super sensitive compass to figure out how those tiny compass needles are pointing at the atomic level.
So each magnetic state has its own fingerprint.
Yeah, you could say that.
That's so cool.
Oh.
But let's shift gears a little bit. We've been gushing about the potential of altermagnetism, but are there any roadblocks researchers are facing? Challenges?
Oh, absolutely. I mean, one of the biggest challenges is figuring out how to control these magnetic whirlpools at room temperature. Right now, a lot of the research is being done at super low temperatures.
Right, because if we want to have, altermagnetism powered phones and laptops, it can't only work when it's freezing cold.
Exactly. And then there's the issue of scalability. Right now, we've only seen these whirlpools in a few very specific materials. Can we, create them reliably in other materials? Can we produce them on a large scale?
Yeah, that makes sense. It's like we've discovered this amazing new ingredient, but we still need to figure out the recipe, right?
Yep, that's a great analogy. And it's not just about the recipe for the material itself. We also need to develop new techniques to manipulate and control these whirlpools. It's like we're learning to conduct an orchestra, but with magnetic whirlpools instead of instruments.
Okay, so there are definitely some hurdles, but it sounds like scientists are making progress. Are there any areas of research that seem particularly promising?
Absolutely. One area that has people excited is the study of topological materials.
Topological material.
Yeah, they're materials with these unique electronic properties that are super robust. They're resistant to change.
So even under extreme conditions.
Yeah, and this makes them very promising for things like quantum computing, where stability is super important.
So how does altermagnetism fit into all of this?
Well, scientists think altermagnetism could lead to even more stable topological spin textures, like magnetic skyrmions.
Wait, so those tiny magnetic whirlpools, those skyrmions, could be the key to unlocking quantum computing.
That's what researchers are exploring. It's still early days, but the potential is huge.
Wow. Okay, this is all very exciting, but let's bring it back down to earth for a moment. What about practical applications? What kind of real-world devices could we see with this technology?
Ooh, the possibilities are endless. One area is data storage. Imagine hard drives that are thousands of times denser than what we have today, all thanks to those tiny magnetic whirlpools.
So we're talking about storing all the world's information on something the size of a fingernail.
Potentially, yeah. And remember those energy-efficient spintronic devices?
The ones that could last for weeks on a single charge.
Exactly. Altermagnetism could be the key to making that a reality.
Sign me up. But seriously, the implications for energy efficiency are huge.
Right. It could change everything. And it goes beyond just energy efficiency. We could also see breakthroughs in sensing, imaging, maybe even medical technology.
Wow. Okay, so Altermagnetism could potentially impact almost every aspect of our lives. But with all this potential, I have to ask, are there any, ethical considerations we need to be thinking about?
Absolutely. We need to think about things like responsible sourcing and manufacturing of these materials. We don't want to create new problems while we're trying to solve old ones.
Right. And what about the potential impact on society? How do we ensure that this technology benefits everyone?
That's a really important question. We need to make sure that access to this technology is equitable.
So everyone benefits, not just a select few.
Exactly.
Well, it sounds like we have a lot to think about. I feel like I've learned so much about altermagnetism already.
Me too. And we're not even done yet.
No.
It really is amazing to think about, something as seemingly simple as the arrangement of atoms can lead to these mind-blowing properties.
Yeah. And it makes you wonder, what other secrets are still out there just waiting to be discovered?
Right. I mean, for centuries, magnetism was this mysterious force. We could observe it, but we couldn't really explain it.
It's like magic almost.
Exactly.
Yeah.
And now we're not only starting to understand the fundamental principles behind it, but we're also discovering these whole new forms of magnetism.
Like altermagnetism.
Exactly. It's like we're constantly finding new rooms in a house we thought we knew so well.
That's a great analogy. It's a good reminder that there's always more to learn, even in areas that we think we've got all figured out.
And that's what makes science so exciting, always pushing the boundaries, always discovering something new.
Speaking of pushing boundaries, one of the things that's really interesting about altermagnetism is how it brings together all these different scientific disciplines.
Oh, absolutely. It's like the perfect example of interdisciplinary collaboration. You've got physicists, materials scientists, chemists, computer scientists all working together.
It's like a giant jigsaw puzzle, where each piece represents a different field of science.
Yeah. And you need all the pieces to see the full picture.
And that's where altermagnetism really shines, right? It's a discovery that wouldn't have been possible without all those different perspectives coming together.
Exactly. And it makes you wonder, what other amazing discoveries are out there just waiting to be made.
It's both exciting and a little bit humbling to think about all the mysteries that are still out there waiting for us.
It really is. But it's important to remember that science isn't just about abstract theories and complicated equations.
Right. It's about using what we learn to solve real-world problems and make a positive impact.
Exactly. And that's where altermagnetism could really make a difference.
Whether it's revolutionizing computing, developing more sustainable technologies, or even helping us understand high-temperature superconductivity, altermagnetism has the potential to change the world in some really amazing ways.
It's a good reminder that even small discoveries can have a huge impact.
Absolutely. So Jenna, as we wrap up this deep dive into the world of altermagnetism, what's the one thing you want our listeners to take away from this episode?
That we're living in a time of incredible scientific discovery. Altermagnetism is just one example of how our understanding of the world is constantly evolving, so stay curious, keep asking questions.
I love that. And to all our listeners out there, we want to hear from you. What are your wild theories about the future of magnetism? What crazy applications can you envision for this mind-blowing technology?
Let us know. Maybe we'll even feature some of your ideas on our next episode.
That's it for this episode of Complicated Stuff. Thanks for joining us on this incredible journey into the world of altermagnetism. Until next time, stay curious.